Video graphics array refers specifically to the display hardware first introduced with the IBM PS/2 line of computers in 1987, but through its widespread adoption has also come to mean either an analog computer display standard, a 15-pin D-subminiature VGA connector, or the 640x480 resolution itself. While this resolution was superseded in the personal computer market in the 1990s, mobile devices have only caught up in the last few years. VGA was the last IBM graphics standard to which the majority of PC clone manufacturers conformed, making it today the lowest common denominator that virtually all post-1990 PC graphics hardware can be expected to implement. Versions of Microsoft Windows released before Windows Vista, for example, display their splash screens while still in VGA mode, meaning that the screens appear in reduced resolution and with reduced color depth. Vista and newer versions make use of the VESA BIOS extension supported by newer graphics hardware so that their splash screens appear in a higher resolution. VGA was officially followed by IBM's Extended Graphics Array standard, but it was effectively superseded by numerous slightly different extensions to VGA made by clone manufacturers that came to be known collectively as Super VGA. Today, the VGA analog interface is used for high-definition video including 1080p and higher. While the VGA transmission bandwidth is high enough to support even higher resolution playback, there can be picture quality degradation depending on cable quality and length. How discernible this quality difference is depends on the individual's eyesight in the display. When using a DVI or HDMI connection, especially on larger-sized LCD LED monitors or TVs, quality degradation, if present, is prominently visible. Blu-ray playback at 1080p is possible via the VGA analog interface, if image constraint token is not enabled on the Blu-ray disc. Output capabilities. The VGA supports both all-points addressable graphics modes, and alphanumeric text modes. Standard graphics modes. Standard graphics modes are 640x480 in 16 colors or monochrome, 640x350 or 640x200 in 16 colors or monochrome, 320x204 or 16 colors, 320x200 and 256 colors, the 640x480 16 color and 320x200 256 color modes had fully redefinable palettes, with each entry selectable from within an 18-bit RGB table, although the high-resolution mode is most commonly familiar from its use with a fixed palette under Microsoft Windows. The other color modes defaulted to standard EGA or CGA-compatible palettes, but could still be redefined if desired using VGA-specific commands. Higher resolution and other display modes. Higher resolution and other display modes are also achievable, even with standard cards and most standard monitors. On the whole, a typical VGA system can produce displays with any combination of 512 to 800 pixels wide, in 16 colors, or 256 to 400 pixels wide, in 256 colors, with 200 or 350 to 410 lines at 70 Hz refresh rate, or 224 to 256, or 448 to 512 lines at 60 Hz refresh rate, 512 to 600 lines at reduced vertical refresh rates, depending on individual monitor compatibility. 175 to 205 line modes may be possible at 70 Hz, and 256 to 300 lines in the 50 to 60 Hz refresh rate range, as well as horizontal widths below 256/512, but these are of little practical use. For example, high-resolution modes with square pixels are available at 768x576 or 704x528 in 16 colors, or medium-low resolution at 320x240 with 256 colors. Alternatively, extended resolution is available with fat pixels and 256 colors using, for example 400x600 or 360x480, and thin pixels, 16 colors and the 70 Hz refresh rate with for example 736x410 mode. Narrow modes such as 256x224 tend to preserve the same pixel ratio as in, for example, 320x240 mode unless the monitor is adjusted to stretch the image out to fill the screen, as they are derived simply by masking down the wider mode instead of altering pixel or line timings, but can be useful for reducing memory requirements and pixel addressing calculations for arcade game conversions or console emulators. Standard text modes. Standard text modes, 80x25 character display, rendered with a 9x16 pixel font, with an effective resolution of 720x400 in either 16 colors or monochrome, the latter being compatible with legacy MDA-based applications. 40x25, using the same font grid, for an effective resolution of 360x400, 80x43 or 80x50 in 16 colors, with an effective resolution of 640x344 or 640x400 pixels. As with the pixel-based graphics modes, additional text modes are technically possible with an overall maximum of about 100x80 cells and an active area spanning about 88x64 cells, but these are rarely used as it usually makes much more sense to just use a graphics mode, with a small, perhaps proportional font, if a larger text display is required. One variant that is sometimes seen as 80x30 or 80x60, using an 8x16 or 8x8 font and an effective 640x480 pixel display, which trades use of the more flickery 60Hz mode for an additional 5 or 10 lines of text and square character blocks. Technical details, circuitry design. VGA is referred to as an array instead of an adapter, because it was implemented from the start as a single chip, replacing the Motorola 6845 and dozens of discrete logic chips that covered the full-length ISA boards of the MDA, CGA, and EGA. Its single-chip implementation also allowed the VGA to be placed directly on a PCA Euro2S motherboard with a minimum of difficulty, and the first IBM PS/2 models were equipped with VGA on the motherboard. Specifications. The original VGA specifications are as follows: 256 KB video RAM, 16 color and 256 color paletted display modes. 262,144 color global palette, selectable 25.175 MHz or 28.322 MHz master pixel clock, usual line rate fixed at 31.469 kHz, maximum of 800 horizontal pixels, maximum of 600 lines, refresh rates at up to 70 Hz, vertical blank interrupt, planar mode, up to 16 colors, packed pixel mode, 256 colors, hardware smooth scrolling support, no hardware sprites, no blitter, but supports very fast data transfers via VGA latch registers. Some raster op support, barrel shifter, split screen support, 0.7 of E peak-to-peak, 75 ohm double-terminated impedance, as well as the standard modes. VGA can be configured to emulate many of the modes of its predecessors, including their reduced global color palettes and coarser text font grids. Compatibility is almost full at BIOS level, but even at register level, a very high value of compatibility is reached. VGA is not directly compatible with the special IBM PCJR or HGC video modes, despite having sufficient resolution, color, refresh rate and memory capabilities. Any emulation of these modes has to be performed in software instead. Signal timings. The intended standard value for the horizontal frequency of VGA is exactly double the value used in the NTSC-M video system, as this made it much easier to offer optional TV out solutions or external VGA to TV converter boxes at the time of VGA's development. The formula for the VGA horizontal frequency is thus a 525 kHz equals 4500 143 kHz per mil 31.4685 kHz. All other frequencies used by the VGA card are derived from this value by integer multiplication or division. Since the exactness of quartz oscillators is limited, real cards will have slightly higher or lower frequency. All derived VGA timings can be varied widely by software that bypasses the VGA firmware interface and talks directly to the VGA hardware, as many MS-DOS-based games did. However, only the standard modes, or modes that at least use exactly the same H-sync and near-exact V-sync timings as one of the standard modes, can be expected to work with the original late 1980s and early 1990s VGA monitors. The use of other timings may in fact damage such monitors and thus was usually avoided by software publishers. Later multisync CRT monitors were usually much more flexible, and in combination with later SVGA graphics cards, could display a much wider range of resolutions and refresh rates at wholly arbitrary sync frequencies and pixel clock rates. VGA options, often XGA as well, and far more besides in more upmarket examples. For the most common VGA mode, the horizontal timings are, total horizontal sync and blanking time equals 6.356 AA microsecond. Equivalent to pixel widths of A equals 16, B equals 96, C equals 48, D equals 640 and each complete line equals 800. NB. The figures shown in this image may be slightly inaccurate and not match the above table exactly. The same general layout applies, merely at a lower frequency, for the vertical timings. These timings are exactly the same in the higher frequency mode, but all pixel counts are correspondingly multiplied by 9/8 THS, thus, 720 active pixels, 900 total per line, and a 54-pixel back porch. The vertical timings are, total vertical sync and blanking time 1.43 ms. Equivalent to line periods of A equals 10, B equals 2, C equals 33, D equals 480 and each complete frame equals 525, these timings are somewhat altered in 70 Hz mode, as although it uses the same line rate, its frame rate is not quite exactly 7/6 THS that of 60 Hz, despite 525 dividing cleanly into 7, and, of course, 480/400 is itself a larger 6:5 ratio. Instead, it compromises on a 449-line frame, with the back porch extended to 34 lines, and the front porch to 13, with an unaltered 2-line sync pulse, and the active image taking up 89% of the total scan period rather than 91%. The monitor is triggered into synchronizing at the higher frame scan rate by use of a positive polarity sync pulse, versus the negative pulse of 60 Hz mode. Depending on manufacturer, the exact details of active period and front-back porch widths, particularly in the horizontal domain, may vary slightly. This does not usually cause a problem as the porches are merely intended to act as blank video buffers offering a little overscan space between the active area and the sync pulse and thus can be safely overrun into by a certain amount when everything else is operating correctly. The relationship between the front and back porches can also be altered within certain limits, which makes possible special features such as software-based image alignment with certain graphics cards. This buffer zone is typically what is exploited to achieve higher active resolutions in the various custom screen modes, by deliberately reducing porch widths and using the freed-up scan time for active pixels instead. This technique can achieve an absolute maximum of 704 pixels horizontally in 25 MHz mode and 792 at 28 MHz without altering the actual sync width, and as much as 523 or 447 lines at the standard 60 and 70 Hz refresh rates. Conveniently, the practical limits of these techniques are not quite high enough to overflow the available memory capacity of typical 256 KB cards, so the only concerns remain those of monitor compatibility. Typical uses of selected modes. 640x400 at 70 Hz is traditionally the video mode used for booting most VGA-compatible x86 personal computers, which show a graphical boot screen. 640x480 at 60 Hz is the default MIS Windows graphics mode, up to Windows 2000. It remains an option in XP and later versions via the boot menu low-resolution video option and per application compatibility mode settings. 320x200 at 70 Hz is the most common mode for VGA-era PC games, using exactly the same timings as the 640x400 mode, but halving the pixel rate and displaying each line of pixels twice. The actual timings vary slightly from the defined standard. For example, for 640x480 at 60 Hz, a 25.17 AA microsecond active video time with a pixel frequency of 25.174 MHz gives 634 pixels, rather than the expected 640. Connectors. VGA uses a DE15 connector. This connector fits on the mounting tab of an ISA expansion card. An alternative method of connecting VGA devices that maintains very high signal quality is the BNC connector, typically used as a group of 5 connectors, one each for red, green, blue, horizontal sync, and vertical sync. With BNC, the coaxial wires are fully shielded end-to-end and through the interconnect so that no crosstalk or external interference is possible. However, BNC connectors are relatively large compared to the DE15, and some attention is needed to make sure each cable goes to the correct socket. Additionally, extra signal lines such as +5E, DDC, and DDC2 are not supported using BNC connectors. Standard text modes. The BIOS offers some text modes for a VGA adapter, which have 80x25, 40x25, 80x43 or 80x50 text grid. Each cell may choose from one of 16 available colors for its foreground and 8 colors for the background. The 8 background colors allowed are the ones without the high-intensity bit set. Each character may also be made to blink. All that are set to blink will blink in unison. The blinking option for the entire screen can be exchanged for the ability to use all 16 colors for background. All of these options are the same as those on the CGA adapter as introduced by IBM. Like EGA, VGA supports having up to 512 different simultaneous characters on screen, albeit in only 8 foreground colors, by rededicating one color bit as the highest bit of the character number. The glyphs on 80x25 mode are normally made of 9x16 pixels. Users may define their own character set by loading a custom font onto the card. As character data is only 8 bits wide on VGA, just as on all of its predecessors, there is usually a blank pixel column between any 2 horizontally adjacent glyphs. However, some characters are normally made 9 bits wide by repeating their last column instead of inserting a blank column, especially those defining horizontally connected IBM box drawing characters. This functionality is hardwired to the character numbers CO hex to DFHEX, where all horizontally connecting characters are found in codepage 437 and its most common derivatives. The same column repeating trick was already used on the older MDA hardware with its 9x14 pixel glyphs, but on VGA it can be turned off when loading a font in which those character numbers do not represent box drawing characters. Monochrome modes. VGA adapters usually support both monochrome and color modes, though the monochrome mode is almost never used, and support for the full set of MDA text mode attributes is often missing. Black and white text on nearly all modern VGA adapters is drawn by using gray-colored text on a black background in color mode. VGA monochrome monitors intended primarily for text were sold, but most of them will work at least adequately with a VGA adapter in color mode. Occasionally, a faulty connection between a modern monitor and video card will cause the VGA part of the card to detect the monitor as monochrome. This will cause the BIOS and initial boot sequence to appear in grayscale. Usually, once the video card's drivers are loaded, they will override this detection and the monitor will return to color. Addressing details. The video memory of the VGA is mapped to the PC's memory via a window in the range between segments 0x A0000 and 0xBFFFF in the PC's real mode address space. Typically, these starting segments are 0xA0000 for EGA VGA graphics modes, 0xB0000 for monochrome text mode, 0xB8000 for color text mode and CGA-compatible graphics modes. Due to the use of different address mappings for different modes, it is possible to have a monochrome adapter and a color adapter such as the VGA, EGA, or CGA installed in the same machine. At the beginning of the 1980s, this was typically used to display Lotus 1-2-3 spreadsheets in high-resolution text on a monochrome display and associated graphics on a low-resolution CGA display simultaneously. Many programmers also used such a setup with the monochrome card displaying debugging information while a program ran in graphics mode on the other card. Several debuggers, like Borland's Turbo Debugger, D86 and Microsoft's CodeView could work in a dual monitor setup. Either Turbo Debugger or CodeView could be used to debug Windows. There were also DOS device drivers such as OXes, which implemented a serial interface simulation on the monochrome display and, for example, allowed the user to receive crash messages from debugging versions of Windows without using an actual serial terminal. It is also possible to use the mode mono command at the DOS prompt to redirect the output to the monochrome display. When a monochrome adapter was not present, it was possible to use the 0xb000 0xb7ff address space as additional memory for other programs. Color palette. The VGA color system is backward compatible with the EGA and CGA adapters, and adds another level of configuration on top of that. CGA was able to display 16 fixed colors, and EGA extended this by allowing each of the 16 colors to be chosen from a 64-color palette. VGA further extends this scheme by increasing the EGA palette from 64 entries to 256. 2 more blocks of 64 colors with progressively darker shades were added, along with 8 blank entries that were set to black. In addition to the extended palette, VGA adds a second level of indirection. Unlike EGA's fixed 64-color palette, each of VGA's 256 palette entries could be assigned an arbitrary color value through the VGA DAC. The EGA BIOS only allowed 2 bits per channel to represent each entry, while VGA allowed 6 bits to represent the intensity of each of the 3 primaries. This provided 64 different intensity levels for each of red, green and blue, resulting in 262,144 possible colors, any 256 of which could be assigned to the palette. This method allowed new VGA colors to be used in EGA and CGA graphics modes, providing one remembered how the different palette systems are laid together. To set the text color to very dark red in text mode, for instance, it will need to be set to one of the CGA colors. This color then maps to 1 in the EGA palette. In the case of CGA color 7, it maps to EGA palette entry 42. The VGA DAC must then be configured to change color 42 to dark red, and then immediately anything displayed on the screen in light gray will become dark red. This feature was often used in 256-color VGA DOS games when they first loaded, by smoothly fading out the text screen to black. While CGA and EGA compatible modes only allowed 16 colors to be displayed at any one time, other VGA modes, such as the widely used mode 13 hours, allowed all 256 palette entries to be displayed on the screen at the same time, and so in these modes any 256 colors could be shown out of the 262,144 colors available. Programming tricks. An undocumented but popular technique nicknamed Modex or tweaked VGA was used to make programming techniques and graphics resolutions available that were not otherwise possible in the standard mode 13 hours. This was done by unchaining the 256 KB VGA memory into 4 separate planes, which would make all of VGA's 256 KB of RAM available in 256 color modes. There was a trade-off for extra complexity and performance loss in some types of graphics operations, but this was mitigated by other operations becoming faster in certain situations. Single-color polygon filling could be accelerated due to the ability to set 4 pixels with a single write to the hardware. The video adapter could assist in copying video RAM regions, which was sometimes faster than doing this with a relatively slow CPU to VGA interface. The use of multiple video pages in hardware allowed the programmer to perform double buffering, triple buffering or split screens, which, while available in VGA's 320x216 color mode, was not possible using stock mode 13 hours. Most particularly, several higher, arbitrary resolution display modes were possible, all the way up to the programmable limit of 800x600 with 16 colors, as well as other custom modes using unusual combinations of horizontal and vertical pixel counts in either color mode. Software such as Fractant, XLIB and ColorX also supported tweaked 256 color modes on standard adapters using freely combinable widths of 256, 320, and 360 pixels and heights of 200, 240 and 256 lines, extending still further to 384 or 400 pixel columns and 576 or 600 lines in rare cases, as well as other arbitrary sizes in between. However, 320x240 was the best known and most frequently used, as it offered a standard 40-column resolution and 4:3 aspect ratio with square pixels, so much so that Mode X itself became generally synonymous with 320x240x8. The highest resolution modes were only used in special, opting cases rather than as standard, especially where high line counts were involved. Standard VGA monitors had a fixed line scan rate, multisync monitors being, at the time, expensive exotica, and so the vertical frame refresh rate had to be reduced in order to accommodate them, which increased visible flicker and thus eye strain. For example, the highest 800x600 mode, being otherwise based off the matching SVGA resolution, reduced the refresh rate from 60 Hz to about 50 Hz. These modes were also outright incompatible with some monitors, producing display problems such as picture detail disappearing into overscan, vertical roll, poor horizontal sync or even a complete lack of picture depending on the exact mode attempted. Due to these potential issues, most VGA tweaks used in commercial products were limited to more standards-compliant, monitor-safe combinations, such as 320x240, 320x400, and 360x480 in 256 colors, or double the 8-res and 16-color mode. Hardware manufacturers. Several companies produced VGA-compatible graphic board models. ATI, Graphics Solution Plus, Wonder Series, Mac Series, S3 Graphics, S3 911, 911A, 924, 801, 805, 805i, 928, 805p, 928p, S3 Vision Series, S3 Trio Series, Matrox, Magic RGB, Plantronics, ColorPlus, Paradise Systems, PEGA1, PEGA1A, PEGA2A, Scene Labs, ET3000, ET4000, ET6000, Cirrus Logic, CLGD400, CLGD500 and CLGD5000 series, Trident Microsystems, TVGA 8000 series, TVGA 9000 series, TGUI 9000 series, IIT, NEC, Chips and Technologies, SIS, Taymorak, Realtek, Oak Technology, LSI, Hoelen, Cornerstone Imaging, Winbond, AMD, Western Digital, Intergraph, Texas Instruments, Gemini, Genoa. See also, Graphic Display Resolutions, List of video connectors, List of monochrome and RGB palettes, List of 16-bit computer hardware palettes, List of defunct graphics chips and card companies. References. Further reading, J.D. Neal. VGA chipset reference. Hardware-level VGA and SVGA video programming information pager, Jordan Brown and John Kingman. CHRP VGA display device binding to IEEE 1275 a Euro 1994 standard for boot firmware 1.0 HINA. VGA interface and video signal documents. Signal level VGA and SVGA video information pager, IBM VGA Technical Reference Manual. This is the original IBM reference. The document provides good overview of VGA functionality and is fairly complete, including a detailed description of standard BIOS modes and some programming techniques. External links, VGA pinout and signals descriptions.